Hi guys, welcome to Stats Online. We are in lesson 3.2 and today we're going to be talking about sampling and how some sampling is good and some sampling is not so good. By the end of today's lesson, you should be able to describe the different type of samples, the sampling that can lead to bias. And then I want you to be really good at explaining how a random sample can help us to avoid bias. All right, so let's take a look at the statistical question. Which one is a statistical question? Is it the first question or the second question down here below? How tall is the elm tree in Laura's backyard? That's not very statistical. Why? Well, because our answer is not going to vary. If we look at one single elm tree in Laura's backyard, it's just going to give us one number, right? The height that represents that tree, so it's not statistical. The second question, however, is statistical. How tall is the elm trees on Elm Street? Why is it statistical? Well, because all of the trees on that street are probably going to vary in height size, and so that would give us a statistical question. All right, so before we move on, just make sure in your notes you have a nice, beautiful title. You have written down that learning target that will help you understand when you're going back through your notes what we were really trying to learn that day or today. And then let's go ahead and get started with bias. So we're all familiar with the word bias, but in a design of a statistical study, right, if it shows bias, it is going to consistently overestimate or underestimate the value that we want to know in the study when it's repeated many times. Okay, so that's what you're looking for if that study has some bias to it. So we're going to take a look at a convenience sample. So a sample that is based on convenience, right? Choosing individuals from the population who are easy to reach is called a convenience sample. Now guys, convenience samples, they often lead to bias. Now think about those times in class where we would ask everyone in class. That kind of is a convenience sample, isn't it? But I want you guys to caution when you do this. Your convenience sampling often produces unrepresentative data. So let's take a look at an overarching problem for today's lesson. So a school nurse wants to know if students in his school are overweight on average. So one day after school, he walks over to the gymnasium across the hall and from his office and selects the first 20 students that he sees. He weighs these 20 students and uses the sample mean weight as an estimate for the mean weight of all the students in the school. So I want you to explain why this sampling method is biased. So you should be able to kind of think, well, that's pretty much convenient for him to leave his office, go across the hall, and pick the first 20 students that he sees. But why would this lead to a bias study? Well, if it's after school and he walks over to the gym and selects the first 20 students that he sees, yeah, it's a convenience sampling, but it leads to bias because those 20 students after school are probably athletic, right? How many students stay after school and want to be in the gym? Usually those are athletic students. So what's going to happen is that in his study, the mean weight of the students is likely to be less than the mean average of the whole school, which is what he's trying to find, right? It underestimates the average mean weight because most of those students are probably not going to be overweight. They're probably going to be extremely fit. All right, so Ann Landers once asked readers in her long-running advice column, if you had to do it all over again, would you have children? She received nearly 10,000 responses, and almost 70% said no. What? Is it true that 70% of the adults out there regret having children? There's just no way. There's no way at all. So when people feel strongly about an issue, particularly people with strong negative feelings, they're more apt to go out of their way to respond, right? And so this is called a voluntary response sample. It consists of people who choose to be in the sample regarding just an overall invite. And so if you just put it out there, hey, everybody, I want to know if you'd regret having children or not. I mean, if you're like reading, go, I'm just not going to respond. If your kid just made you mad, you'd be like, absolutely not. You know what I mean? So that right there can lead to bias. So let's go back to the nurse. The school nurse from the previous example decides to obtain a sample of 20 students in a different way. Good. He submits in the morning announcement stating health data needed. If you're willing to be weighed, please come down to the health room sometime this week. Well, this is voluntary response sample, right? Because students who are just going to go down if they want to. Now, I don't know about you, but I do not know a lot of very overweight people who are like, yes, weigh me right now. Because I don't even like to be weighed. When I go to the doctor, I tell them, do I really have to? I don't really want to at all. I don't ever want to be weighed. And that kind of happens as you get older, to be honest. But anyways, so those students are more likely to be more fit, the ones that are going to volunteer themselves. And so this would also underestimate the mean weight of the whole school. All right, so we have two sampling, a convenience sampling and voluntary sampling. They will lead to bias. So the best way to avoid a chance of getting a bias results is random sampling. So random sampling involves using a chance process to determine which of the members of the population are going to be included in that sample. So I think of like putting every single student, like putting their names like in the class. If I want to like pick someone randomly to answer, I just have all their names on slips of paper and put them in a hat and pick it out randomly. This is the student I call on. So that would be an example of choosing a random sample. All right, so here, let's go back to the nurse, right? So I want you to explain how the nurse could avoid bias identified in the previous examples. Like, what could this nurse do? Well, I think that, let's say there's like 900 students in the school. It would not make sense to put 900 students' names on paper and draw from a hat. But what you could do is you could give every single student in the building a number, right? 1 through 900. And then have a random generator, like a software technology that just randomly generates a number, and then you choose however big your sample size is, and you would choose that number, and then they would get weighed. So that would be one way of doing a random sample. Now, if we were all in class right now, I would ask you, like, what else? Do you guys have any other ideas? And then we would talk about it, and then and I missed that. So, okay. Well, I hope that you guys are having a great day, and I will see you at the next lesson. All right. Bye, guys.